or space-based AI, energy is the ability to take action. So the more energy you have, the larger your ability to take action. Intelligence is action, discriminated action. So you want to do things and you want to find a way to run counterfactuals of what you do. In other words, you want to say, this is better than that. This is better than that. No matter what kind of algorithm you're choosing in AI, any kind of learning algorithm has to be discriminative. In other words, it has to have a way to decide this versus that. And it actually is binary. The unit of analysis is binary. You can have a very complex model with attention and all kinds of things, or some future model, but it will always be reduced to this or that. Now, this or that is best done in what we call dot products. Dot products are mathematical concepts, for example, vectors, and the dot product shows how aligned vectors are. So this or that could be translated into mathematics by, if I turn left, then I am more aligned with my goal, which is, let's say, the vector x, and turning left gives me a vector y, and that vector y is more aligned with x than if I turn right, and turning right gives me vector z. So z is less aligned with x than vector y. Therefore, the dot product is higher if I do the dot product between y and x versus z and x. So the dot product gives me an assessment, a mathematical, quick, dirty assessment of how aligned vectors are, and if I reproduce the world in vector space, so which means I assume all the data points are in some sort of vector space, then I can do dot products to align myself with a certain goal, which would be a certain vector that I'm trying to align myself with. Now back to power. Power is energy per time or work per time. And the more work I can do in a certain amount of time, the more power I have. So work being moving voltages around the GPU, that's work. The more I can do that, the more power I have, the more work I can do. And work is really the backbone of intelligence, because intelligence is, in physics terms, voltages being moved around and moved back and forth from memory and things like that, computations being done. All of this is work. And you can also think about it in a more meta way, which is that I can either find out which valley of the 5 valleys has a lake, or I can do some math and AI and use mapping or imaging technology to find out where that lake is, and then save myself the actual try and error, sort of walking into the valleys. So I like to use that example of the Swiss Alps because probably I think about these things a lot when I'm hiking. But the point is, instead of me going up and down 6 valleys to find out which lake is the highest, maybe I can do some math and AI to find out. So it saves me work, or it's inverse work. And in order to get that savings of work, I need to do work, because there's a conservation of energy and also conservation of momentum. I can't just come up with something without investing something else. So to summarize, I think the point of power, energy, work, and intelligence, all of these things are related. They're all the same they're all values in the same dimension. And the fundamental idea of corner space is to increase the availability of energy at orders of magnitude, and therefore generate more work and generate more intelligence.